Okay, let's perform some operations on scientific notation problems. And I want to remind you of the rules that pretty much the general rules for algebra that when you add or subtract, you can only add and subtract things that are alike. And we're always going to reference back to this. You can add and subtract when things are alike and they stay alike. You can multiply anything. You can divide anything. The way you multiply and divide is you multiply the parts that are alike. And when you divide, you do the exact same thing. So this problem is just like this problem. You can add and subtract when things are alike. The number out front tells you how many of something you have. It's called a coefficient. So in this problem up here, you have 3x's plus 4x's. Here you have this many 10 to the fourth, and you have this many 10 to the fourth. You can add, subtract anything. When you add them together, they stay alike. So since these are alike, you have 3.5 of them, 2.7 of them. You're simply going to add the coefficients, and that gives you 6.2 times they stay alike. 6.2 times 10 to the fourth. Same way with subtraction. The only issue is with scientific notation, again, these have to be alike before you can add or subtract. So what we're going to have to do is we're going to have to somehow make them alike. So we can change either one, does not matter, but we need them both to be 10 to the fourth or both of them to be 10 to the thirds. So here's the issue. We've got to take, and 10 to the third means we've got to move this decimal place over 3 times. However, if we put it here, now to get it in the right place, we'd have to move it over 4 times, which is what we want. We want a 10 to the fourth, so let's do 9.3 times 10 to the fourth minus. If we put our decimal in front of the 0.6, or in front of the 6, now that's also going to be a 10 to the fourth. Now we're simply going to, again, they're alike. They're both 10 to the fourth now. So we're only worried about the coefficients. When things are alike, you can add or subtract them, and they're going to stay alike. So now we're going to do 9.3 minus 0.64, and I've already got that typed in. You get 8.66 times, they stay alike, 10 to the fourth power. Just make sure your answer is in correct standard scientific notation like it's supposed to be. Next one's a little bit trickier. Again, you're adding these together. These are not alike, so we've got to make sure that we've got to change them to where they are alike. And I'm going to work this one the long way. I'm actually going to change the first one. It doesn't matter which one you change. But 10 to the negative 2 means I've got to take my decimal and I've got to move it 2 places left. However, if in order to make that 10 to the negative 3, if I put it here, now I've got to move it 3 places to the left. So therefore, that's what we want to do. 43.1 times 10 to the negative 3 plus 5.1 times 10 to the negative 3. When we add those together, all I've got to do is add the coefficients now. I get 48.2 times 10 to the negative 3. However, look, my decimal's in the wrong spot. In order to be correct scientific notation, I need it to be between that 4 and that 8. 10 to the negative 3 says where the decimal's at now, it needs to move 3 places to the left. Well, if I move it to 4.82, now in order to get to the right spot, I'd only have to move it 2 places to the left. So now I've got it in correct scientific notation. Okay, the next problem, we're going to multiply. Now, quick reminder that you can multiply anything. 3x times 4x squared. Those are not like terms. They're not, the x's are different, but the way you multiply is you combine the things that are like. 3 times 4 goes together, x times x squared goes together, and we're just going to use some basic rules of exponents. Now, quick reminder about your rules of exponents. X squared times x to the third gives you x to the fifth. We are going to have to know that going through these problems. So again, we have everything's being multiplied. We're going to multiply the things that are alike. 2.1 times 3 is 6.3. 10 to the fourth and 10 to the second's alike. So this rule of exponents I just showed you, you have 4 2s and 4 10s, 2 more 10s. That's a total of 6 10s, and you're done. So multiplication's a whole lot easier. The next one, again, we're going to combine the things that are alike, the 7.2 and the 2.1. When we multiply, it gives me 15.12 times 10 to the, and again, we're using our exponent rule, 10 to the negative 4 and 10 to the fifth. To multiply those together, we're going to add the exponents. That gives me 10 to the first. And when I've got something that small of a power, I usually don't leave my answer in scientific notation. I'm just going to move that decimal over the one time that it asks. 151 0.2 is probably how I'd leave my answer. It'd be kind of silly to leave that in scientific notation. The next one, division. Works the exact same way, but I do want to remind you of your rules of exponents. X to the fifth over x to the second. To divide exponents, you're going to subtract. If the highest power's on top, put your answer on top. If the highest highest power's on bottom, we put our answer on bottom. Now, in this case, since we are dealing with scientific notation, we will have to move it, though. X to the positive 3 on bottom. Anytime you move a power across a fraction bar, if it's positive, it becomes negative. If it's negative, it becomes positive. So if I wanted to move that to the top, it would actually become x to the negative 3. So we'll use those properties and rules. So here we go. In order to divide, now it's very important to point out there's no addition and subtraction, so this is perfectly legal. We simply divide the parts that are alike. 4.2 divided by 2.1 gives you 2. There's 10 tens on top. There's 3 tens on bottom. When you subtract them, it leaves you with 7 tens, and you're done. The next one, same thing. 1.3 divided by 2.5 actually gives you 0.52 times. Rules of exponents. Okay, so got some options here. Since we don't want our scientific notation to have that 10 on bottom, what I'm going to do is move these 10 to the fifth to the top. Moving it to the top becomes negative 5. Now you can put them together, and that's going to be 10 to the negative 9 power. Now, in this answer, my decimal's in the wrong place. And again, this 10 to the negative 9 means I've got to take this decimal, and it's going to move left 9 times. In order to get it to where I want it, though, instead of moving it left 9 times, now I would have to move it left 10 times. So that's going to be written as 5.2 times 10 to the negative 10. All right, last two. Now we're dealing with exponents. Again, very important to point out that there's no plus or minus signs, which makes what I'm about to do legal. Now, 3x squared to the third power. Since there's no plus or minus signs, I can simply raise each of those to the third power, and that's all I'm doing here. I'm going to raise the 2 to the 6th power, and I'm going to raise 10 to the negative 3 to the 6th power. To raise a power to a power, you multiply the powers. So we got 2 to the 6th, which gives you, I believe, 64. Times 10 to the negative 3 to the 6th power is negative 18. So there's my answer, but again, it's in the decimals in the wrong place. So I'm supposed to move this decimal left 18. If I put it here to get it in the right spot, now I'd only have to move it left 17. So that'd be 6.4 times 10 to the negative 17th power. All right, last one. So 1.2, everything's being raised to the negative 3 power, so I'm simply going to raise everything to that negative 3, and I'm going to go ahead and do the 10. Power to power, you multiply, so that's going to be 10 to the negative 18. Now, the hard part is this. What in the world is 1.2 to the negative 3? In order to make a negative exponent positive, again, we bring it to the bottom. So we could work this out by hand. It would take forever. We'd have to do 1.2 to the third power and then divide 1 into that. We can, again, simply type that into our calculator. And I get somewhere around 0.579. So again, let's go through the process. Times 10 to the negative 18 says move your decimal left 18. If I put it where I want it to, now to get it to the right spot, I have to move it left 19. So 5.79 times 10 to the negative 19th power. There's your final answer.